right, so sorry about the delay. First time doing the stream remote like this. Hopefully they'll be a bit buffed out after this experience, but we've got Matthew Bonig here. He's going to talk about the Cloud Developer Kit. Going to go get into that. So yeah, let us know what you guys think about the stream and if we can do anything better in the future. Sorry about the delay again. And the slides are in the chat for the stream. So yeah, Matt, if you want to take it from there, why don't you take this down?
All right, thank you very much, Austin. I appreciate it. Good evening, everybody. Hopefully everyone is out there staying safe and healthy in their houses. We are definitely doing this as a live stream. This is a big experiment. Hopefully everything goes well. Please, as he said, leave all your comments and everything. Today we're going to be talking about the Cloud Development Kit, infrastructure as your code, as I like to say it. If you want to follow me and hear me talk a lot about the CDK, you can follow me on Twitter at Matt Bonig. And in the chat, as well as there at the bottom of the screen, is a link to these slides. So if you want to follow along, you can do that. So first off, who am I? Why am I talking about the CDK? I am a system architect and DevOps engineer. I've been working in both the enterprise and the small business markets for the 17 years or so here in the Denver area. And I am an AWS certified solutions architect. And one thing that some people don't know about me is that my dream job would be to be a mascot for a sports organization or otherwise. I think it'd be the greatest job in the world, and I would really love to do that sometime. Let's get rid of this little notification up here. Perfect. All right, moving right along. So what we're going to be talking about tonight, first, we're going to talk about what's the problem currently that we're trying to solve with CDK. What is the difficulties that we have with managing our AWS infrastructure as code? We're going to talk about how the CDK specifically solves this problem. We're going to talk about 3 specific use cases, and then finally try to put some sort of meaningful conclusion together. Finally, at the end, we'll have a little Q&A. If you can, go ahead and type your questions into the stream, and Austin will keep track of those, and we'll answer those at the end. All right, so let's get started with the problem. The problem is that CloudFormation is very necessary in any sort of meaningful AWS deployment. You could also use Terraform or serverless.com or any of the infrastructure as code, but ultimately the CloudFormation is sort of the first-class citizen, and we generally end up falling back to it. The problem with it is that it can be very painful. It is a DSL. It's declarative language, which means that you're often going to be limited with what you can and can't do in defining your infrastructure. It can be very idiosyncratic. It can be very difficult to remember all the nuances of it, things like that. So if you're writing a lot of CloudFormation templates, you're going back to documents a lot. And finally, it's YAML. I personally am fine with YAML or JSON or any of them, but it is a static file, and there's only just so much you can do, where we as developers are used to dealing with application code, which gives us all the freedom in the world to do whatever we want. If we take a look at one of these YAML files that we would end up building on these CloudFormation templates, there's all these little nuances in here, like using references for things, using attributes for other things, and trying to do a lot of conditional logic can be very, very verbose and very painful. There's just hopefully going to be a better way for us to manage these things going forward. If we take a look here, some of these specific problems. So let's say I want to get an ARN for a particular resource. Well, ultimately, if I want to do it really, really proper, then this is probably how I'm going to write it out. That's neither easily readable or easily maintainable, and it's just a kind of a very odd syntax that you end up with in some cases. Now, admittedly, this is generated syntax at this point. You could write this more succinctly, but ultimately, you end up writing something similar to this, in my opinion. There's also these things like these different functions you're going to call in CloudFormation, like either get attribute or reference or join and all of those. And the get attribute and reference functions themselves have a lot of nuance to them as far as what you can and can't do with them. Again, always having to go back to docs. So can we solve these problems with the Cloud Development Kit? Absolutely, I believe so. So what is the Cloud Development Kit? It is an API that you can consume from other languages like Python or TypeScript or JavaScript. You can use any of the .NET languages to write and to use the CDK. You can use Java. And at the end, once you build all of these, the API is an object model API. So as soon as you build up all these objects, once you're all done with it, you pass them through this synthesize routine. And synthesizing a CDK construct generates that CloudFormation template for you. And then whatever you decide to do with that CloudFormation template is up to you. You can use the CLI to actually deploy this out for a one-stop shop, or you can incorporate it into all of your other sort of deployment pipelines that you've had in place for CloudFormation templates. So let's talk about a quick example so that everyone's on the same page. In this case, this is directly off of the CDK website, but we're going to create a virtual private cloud. A lot of resources that get involved with creating a VPC. We're going to create an ECS cluster so that we can run Dockerized workloads. We're then going to create an application load balancer and that back-end service that functions at that application workload, the website or batch processor or whatever, mostly in this case a website. We're going to create all these things. We're going to do it in TypeScript. If you're not familiar with TypeScript, that's fine. The language itself is pretty C-like, so hopefully readability is just fine. So here we go. This is the one thing that we would have to create for all of that. And it starts off with extending a class. Because this is an object library, because these are object-oriented languages, we are going to go ahead and inherit from this stack object within the CDK namespace, the core namespace. Once we do that, then everything happens through the constructor. And in this case, every construct of the CDK, you handed three things in the constructor. The first is a scope. The second is an ID, and the third is properties that define how that construct is actually going to be built. Those are the dials in the system that lets you customize your code to what you need built. The scope, think of this as a parent-child relationship like the DOM or anything like that. It's just simply an object that is sort of the container for this construct. In the case of a stack, that's what's called an app. But for the case of all the other constructs we build, it's actually going to be this or this stack. So we create a constructor. And the first thing we're going to do is we're going to create this VPC. The VPC is a construct that represents all of the resources that are actually needed within AWS to build out a virtual private cloud. Here we do it with what's essentially one line of code. We say that its scope is this, the stack that we're currently in. We give it an ID of my VPC, and then we give it all the properties. In this case, all we're going to set is how many availability zones or the max AZs that we're going to let this VPC span. That's it. That's all we have to define to get a VPC up and running. So then we move on to an ECS cluster, container services cluster. Again, similar sort of thing. All we're going to give it is the scope, which is this. We're going to give it a new ID, and then we're going to say go run within that VPC that we just created, and we just handed a reference to the object. Finally, we're going to go ahead and create this application load balanced Fargate service. This is an even more complex type of construct in the system. This is going to take care of setting up the ALD for all of your routing needs. It's going to take setting up the ECS cluster, setting up a task definition and all the parameters to run an actual workload within that cluster. We give it just a minimal set of values here. The cluster we want to run, allotment, the desired replication counts and task images. In this case, we're just pointing to a Docker image in an ECR repo. Notice that this is not something that we have created directly within this stack. This is something that has already existed outside resource. We set a memory limit, and then we say, is the load balancer going to be public? And of course, we want it to be public. Once that's all done, we pass this whole thing through the synthesize routine. And as a result, we get a big CloudFormation template. This is part of that template. It's 10 or so pages, I believe like 500 or 600 lines long or something like that. So 12 lines of code that we wrote, and it takes this out into 500 lines. And all along the way, we got a lot of improved readability. So that's what the CDK, as a simple example, is meant to do, and some of the power you get from it. So Let's go ahead and move on and talk about some specific use cases. These are situations that I have run across in my actual work of leveraging the CDK as a DevOps engineer. The first one we're going to talk about is CloudWatch dashboards. Now, if you've ever worked with CloudWatch and dashboards, you know that they're very powerful to give you insight into the current running state of your environment, as well as time series data around basic metrics and things like that. Here we have things like an auto-scaling group's total CPU utilization in the upper left, a number of unhealthy targets on an ALB. Well, if you notice, there's actually a lot of stuff going on here. This actually happened to be a pretty complex system. And building out these dashboards were something we were going to be doing by hand. So let's talk about doing them through some CloudFormation. First off, the biggest problem with it is that your YAML files, if you use YAML for your CloudFormation, have this embedded JSON string in it. And that can be really, really painful to maintain over time. Hurts readability, really makes this a painful thing to build out. And ultimately, you'd probably put some sort of generation in front of that anyway. So let's go and talk about how the CDK solves this. And we're going to look at a very specific portion of this dashboard. In this case, the RDS connections, or the relational database connections used throughout the system. So if I was going to build this in the CDK, the first thing I do is I create a new CDK module using the CDK CLI, and I say init, and in this case, I'm going to use TypeScript as my language. And out of that generates a whole bunch of code for me, boilerplate stock code, and it's going to go ahead and create some of this for me, and I'm going to fill in some extra stuff. So this is what it created for me, basic stuff to import in the API, and then bring in this custom bootstrapped dashboard stack object. That's code within this library that we will continue to change and maintain over time. It built that. I'm going to go ahead and just add in some additional code here. This is calling the AWS CDK, or excuse me, SDK. So making standard SDK API calls against an AWS environment. I can do that now from within my code. You can get all sorts of useful information about my environment. I can go ahead and say, get all of my database instances out of the environment. I filter them down using this complex logic that is all just a standard TypeScript code at this point to get down to the database instances that I want to report on directly. So all those get passed into the constructor as this DB instances. You can see here, there's a bunch of other stuff I'm going to be passing into the properties of this construct along the way. But then within the construct, I'm going to go ahead and start building these things out. Here, I'm going to go ahead and start creating a widget for every single one of these panels up here. So call off into helper functions within this construct that just generate out these individual graphs. Specifically, we're going to continue digging into the RDS connection. And within that code here, we have this RDS connection. So I take all those database instances that were passed into me, and then I just create these new metric objects along the way. And these metric objects are the API that is the CDK. I'm just going to create a bunch of these instances along the way, handing over all the important information about this particular database instance. And at the end, I pass back yet another object called a graph widget that uses all that data that I just put together, all those metrics that I put together. That's it. Go back, implement the methods for all these other guys with similar types of code that takes a look at all that data that I pulled out of AWS API, and go ahead and construct out all these widgets. And at the end, rather than writing this thing here on the left that is all this nasty, hard to read JSON embedded within the YAML file, the code that I read and maintain is standard TypeScript code like this stuff on the right. Much easier to read, much easier to maintain, also unit testable, of course. So that's first case for really managing these database dashboards and environment dashboards. If you have any questions, again, go ahead and type them into the chat. Here at the end, we will go ahead and answer anything that we can. Moving right along, case number 2, complexity. Once you start building infrastructure as code, you find that it's a really fantastic way of maintaining your AWS or your cloud infrastructure. And you want to do it more and more. But that means that you have to start building libraries of your infrastructure as code. In the same way that if we have useful application code, we package that up, we reuse it through menu systems. We want to do that with our CDK code as well. And to really make a lot of this code reusable, it ultimately has to be fairly complex along the way too. In this case, we're going to be talking about a static website, just a standard index.html page for the most part. It's going to be hosted within an S3 bucket with CloudFront in front of it. And then we've also got a continuous deployment. So as soon as code changes within our GitHub repo, we'll automatically go ahead and deploy them out into the environment. And finally, there's the question of certs. We always want to have certs on all of our websites and things like that. So let's talk about getting that built in here as well. If you want to follow along, all of this code is available on my GitHub page at github.com/mbonig/CICD spa website. And we'll have that link in the comments here in a moment. All right, so what does it look like to actually build this thing out? Well, the first thing I have is input properties. I want to know what are the ways, what are the dials that I can use to change the way this infrastructure is built. The first one is simply I have to give a URL. I want to know where this website's going to be hosted as a URL. This allows me to create the Route 53 entries and all sorts of other stuff. The GitHub source, so this is actually a special class or an interface in this case that is a limited version of the standard GitHub source action properties. I just stripped about a bunch of fields, created a new interface for it. There's also a build spec, so how we are going to actually build the website through a code build project. I can either specify an object directly, or I can specify a string value which will point to a file within the source repo. And if you notice, this is optional. If I don't supply anything at all, it's going to use an out-of-the-box node-based build script. So it'll do an npm install, it'll do an npm build, and then copy files accordingly. And that's actually referenced. You can see exactly what it'll do or change it if you need to. All right, certificates, we can either provide a certificate or say that we want a certificate created. And this is really important because we're either going to reference an existing certificate or create a new one. And that's not an easy process sometimes in AWS. And then finally, if we do want to have hosting on all this, we got to supply a hosted zone. So we'll do that here at the bottom, optionally with hosted zone attributes. So we can do that lookup. So here's what our resulting infrastructure with this construct would actually look like. I've got a user. That user is in a browser, and we'll use Route 53 DNS entry to point to an Amazon CloudFront front end for this. That surfaces over an AWS S3 bucket, which I use a code pipeline process to continuously deploy to. Finally, there's a certificate manager that sits here on CloudFront, and that is if you supply all of the input properties. If you supply every one of these, if you supply a certificate, you supply the hosted zone, you supply the URL, then you'll get all of this. But what happens if you don't? So first off, a couple of notes about this. We want that S3 bucket to be private because CloudFront's going to be the public face. We want that bucket policy to be locked down so that obviously no one can write to it, but also nobody can read from it either. We don't want this to be a website hosted bucket. So let's go ahead and say we don't supply a certificate. Well, if we don't supply a certificate to this construct, then we can't create a CloudFront. So in that case, we actually want to change things up a little bit and have the user and the Route 53 DNS entry point to S3 buckets with standard website hosting. But then in that case, the bucket has to be public, and we also have to have that website hosting option turned on and configured properly. So that's a way that now all of a sudden, this is all changing the way that we build these things out. And finally, the deploy process, it's going to be using a public read on all of the objects that it deploys out, whereas before it would be private. Right? If we don't supply a hosted zone or a certificate, then we just create the bucket, we create the CI/CD, and a user is responsible for getting it to it from somewhere else. This is useful in a case where you want to keep your Route 53 entries separate from the rest of your infrastructure so that you can easily swap out that entire infrastructure if you need to without necessarily having to worry about the Route 53 implications and how to rotate those things through. All right? So the best part about all of this is that all of that logic I discussed in there is easily unit testable. I can write up all of my unit tests, I can write up all of my implementation before I actually have to worry about doing integration tests with creating some of these resources. And that's really important because things like CloudFront is a very, very slow resource to provision. So if I go ahead and just create a distribution and that takes a half an hour to run, and then something later in my stack fails, now that distribution also has to roll back. And now I have an hour round trip between iterations of my code. And that's really, really slow. It's not great. So unit testing cuts all that down so I can guarantee a lot of this functionality is correct before I ever have to worry about integration testing. That's it. One final thing, this certificate, whether I provide an existing certificate or I say yes, that I want a certificate created, that actually comes from a very cool module out of the CDK that sits there, and it's called the DNS validated certificate. This is a construct which will go out and create a new certificate in ACM and get it validated through a DNS entry using a custom resource in CloudFormation backed by a custom Lambda that is all baked in to this component. So if I need a new DNS validated certificate, all I do is include this within my project, provide a couple of properties, and I'm running, and it's fantastic. And it's these types of what's called an L3 construct, where you get this additional complexity and this combination of stuff that you really, really start to see the power of the CDK. All right, finally, the build spec. If you want to, you can either define an object or give it a string value, as I said. If not, you can use the one that's built into it. And if you're using a node-based build process, then it'll probably work just fine. So that's a very, very complex process. We got a lot of business logic in there, something that we can reuse in a lot of different projects throughout our organization. It's managed and centrally in one place and takes a lot of workload off of DevOps engineers. It's all unit testable, which is, of course, key to a lot of the benefits of the CDK along the way. It's a lot easier to read and maintain long term, of course. And then finally, you get the power of these L3 constructs. Think of these as like nested stacks and pre-built CloudFormation templates, but they can do a whole lot more along the way, as we saw, even include Lambda code very, very nicely. So finally, we're going to talk about the third use case, application-defined infrastructure. Now, this is where I think that the fact that this is a Python or TypeScript or Java or C# API comes in very, very powerful, and it makes it a very, very unique solution. It allows us to be solid, and it allows us to be dry with our code, which is something that typically we don't get with a lot of static files in CloudFormation natively. And again, if you want to follow along with what I'm about to talk about here with this project, it's available also on my GitHub page at the Simple ES API. So the ES, that stands for event sourcing. And what does that mean in our case? It means that this is a microservice that is completely deployable, standalone on its own. And this microservice is, think of it like a CRUD application for, say, like a customer model. Except that it doesn't use a CRUD model, it uses an event-sourced model. So real quick, how does an event-sourced model work? Well, every time that a user or a client interacts with that customer, it's not that it's creating or updating a record, it's that it's always creating a new event. And that new event is things like create a customer or update a customer, or maybe the customer placed an order. It's a very loose definition for what an event is, but it gets written into a system and then written into a database. Now, at this point, there are 3 Lambda functions that I have shown here. These Lambda functions are all listening to the DynamoDB stream and will all process that event differently. In this case, they'll all process the record and write a new record back into the database, and this is what's called a projected view. Now, sometime later, a user or a client is going to want to see what a customer looks like, and they're going to use a get on the API. That's going to go into this Lambda that just reads off the specific projected view out of the system, reads the correct database record for that particular user and path and things like that. Some keynotes about this, it is, again, just a use case for a very generic, very simple event source data model. In this case, we're talking about it with a customer being in place. But at the back end, when we get into those Lambdas and those handler functions, I have this code that I've written into the system. This is where I define how many projected views I have. I call them event handlers. So I have a default and I have a summary, in this case 2. Now, this means that I have 2 different handlers. I have 2 different lambdas that I need to create within my AWS infrastructure. And normally at this point, what I'd have to do is go back to my infrastructure as code and change some value over there as well to say, okay, now I have summary, or now I have a 3rd view or a 4th view. And I have to sort of duplicate this code in 2 places. Ultimately, all I care about is this title right here, this key of either default or summary in my case. So that's pretty easy. So how can I work this into the CDK? Well, when it comes to going back and working with my construct, I just import that code like it's any other code in my system. I just bring it in. In this case, I bring in is called this index object. And then I just simply get all of the keys off that index event handlers. And what that's going to return back to me then, I'll pass into this CDK code that creates new Lambda functions along the way. Thank you, sir. But I define my code in one place. I sit here and I define my Lambda handlers as an application developer, and the CDK automatically then knows how to create the resulting infrastructure. There's no coordination I have to do with that infrastructure as code. It just automatically brings it in and builds it. That's something that you're not going to get from any other sort of infrastructure as code solution that I know out there. So that's about it here in this 3rd one. So, we could have maybe done some string parsing of our code to maybe get that information if we were going to use something like CloudFormation directly or Terraform or things like that, but nobody wants to write that code. It's really, really painful. So in conclusion, the best part of the CDK is that it still uses the CloudFormation service, which is fantastic. We've relied heavily on the CloudFormation service for years for building out our infrastructure, and it's very, very useful within a pure AWS environment, still very powerful, and we still get to use that. We are just now generating the CloudFormation templates that we use with that system. We get to build really, really complex infrastructure as code, which means that we can overall reduce the total cost of ownership of our infrastructure as code. As we reuse things more and more, it becomes cheaper to have a complex system. And this is all because we're using the native APIs that we're familiar with, so TypeScript, Python, C#. Just as we become polyglot on our application side, we can become polyglot on our infrastructure as code as well. So another thing that we're pulling over from that space. And then, of course, one of the things that I never really talked about otherwise is that because this is all standard code, our IDEs can still give us a lot of IntelliSense and refactoring powers. So as you go through and you unit test your code and you start refactoring and you start to make it more elegant or easier to read or whatever, we still get to use all those tools that we're used to using on the application development side to go ahead and manage this code, which means, again, it's quicker and easier to develop. So if you are interested and you want to go ahead and take this home and start doing some stuff with the CDK, first thing I recommend, go with unit testing. Learn from day one how to properly unit test the system. There's a lot of good documentation on AWS's website for unit testing. There's some good articles and other things online. I would be remiss if I didn't tell you that you should go to the openconstructfoundation.org. This is a website that attempts to really bring together all of the various components of the CDK as a one-stop shop for, okay, here's where I start, here's where I go for examples, here's where I go for guides, here's where I go for the construct catalog, things like that. We start looking into L1 versus L2 versus L3 constructs. An L1 construct is a basic one-to-one mapping with a CloudFormation template resource. They exist in the system, they're generated. You can use them as a release valve if you don't have access to an L2 construct that does what you need. An L2 construct is generally what you're going to be dealing with a lot in the beginning, that are taking things like a S3 bucket or a Lambda function, packaging them up into a nice, easy to use with smart defaults type of object to deal with. And then finally, L3 constructs at the very beginning. Well, most of the things I talked about today were L3 constructs. They're the things that take multiple L2 constructs and put them together in a useful, meaningful way to build some concise piece of business logic. Definitely could check out the construct catalog, the AWS CDK.io. It is a place and a catalog for all third-party created constructs. So the community is definitely getting behind this idea of sharing these pre-built, easy-to-use constructs, and there's some very, very good ones out there to take a look at. That's a good search engine for doing it. And then finally, just try creating some of your own constructs. A very simple one that I built the other day as a demonstration was what I call a secure bucket. So it's an S3 bucket L2 construct. All I do is I provide a couple of smarter defaults, like enable encryption by default and deny public access by default, and I don't even let that option be turned on. That could be a very good construct to deploy out into an organization from a compliance and security standpoint. Try creating something that is simply doing that, overriding basic defaults, and before you start worrying about trying to build really big complex stuff along the way. It's just like application code, start small when you're learning. And again, the openconstructfoundation.org, please check it out. It is an open foundation, so the idea behind that is that anybody can contribute to it. Just submit PRs. There are various links on the website for doing so. If you want to change the website, if you want to submit a guide, you want to submit a how-to, you think that you can make it look better, by all means, please submit PRs to the GitHub repo for anything or issues if you feel like it's something you can't directly develop, and we will try to prioritize it. So that's it for questions. I see that there's been a few coming through on the stream. Let's see here. Okay, so Doug Toppin has got a great question. It would be helpful to show maintaining something that has already been generated and is deployed, meaning how to use the CDK to load an existing project or stack, make changes, and then deploy the update. Okay, so if you want to migrate existing CloudFormation managed resources to the CDK, there is a tool that'll let you basically generate constructs from existing CloudFormation templates, but I don't recommend you use it. It was a more proof of concept project, in my opinion, and what it proved was that it's going to lead you down a very bad path when it comes to managing your CDK code. In most cases, it's worth the effort to rewrite them into L2 and L3 constructs, and then start from the very beginning with that. Now, as far as replacing existing stacks or existing deployed resources, the trick is that when you're defining out your CDK stack in your code, you give it a name like you would everything else. That name matches one-to-one with what you have in AWS. So if you have a stack in AWS called Some Great Website, that's your stack name, then make sure your CD code, the stack that you create there, is also Some Great Website. And then when it does the deploying, when it does the build and things like that, it knows to correlate that existing stack with the new templates that you're generating if you're going to use the deploy mechanism, the CLI. If you manage your stacks manually or through some other process, then that's kind of common for resolving. So. Yes, and it looks like R2D2 masterfully answered my question already. So, is there a GitHub repo for case 1? Asked R2D2. So for the CloudWatch dashboards, no, there is not. That was some specific code that I wrote this last year. I do not have access to it anymore, and it's not really my code to hand out. But if you'd like to see an example of that, by all means, please reach out to me on Twitter. Or submit a PR or an issue to the openconstructfoundation.org's GitHub page. It's in the upper right corner when you log into the site, and I'll be glad to pull one together for you. I believe, okay. So Doug asked again, So as far as the actual resource management, so what have people been doing? Editing the CloudFormation and update stack, or delete and create new resources? Deleting and creating new resources often isn't much of an option. The downside to that is that you have to be very careful then about the IDs that you give all of your constructs so that they match up with the existing logical IDs within your stack. And that is something that is completely within your control. Whether or not you can make that easy to manage within your code base kind of depends on how your objects are made. But that is an approach you can take so that you don't necessarily have to replace anything that already exists, just migrate into the CDK managed process. All right, it looks like that is it for questions. I hope everybody had a good time tonight and learned something. Again, if you have any questions, I'm very active on Twitter. I'd be glad to answer any questions there in the future. And thank you all for coming out tonight to the live stream.
Yeah, appreciate it, Matt. That was awesome. This was some really good content. You could send me, like, if you could send me your Twitter and any other links you want, I could send that out in an email to everybody. Otherwise, I hope everybody like stays safe and stays healthy. And we'll try and keep the cadence going with every 2 weeks. We might not have anything at the end of this month, but we'll probably finish up. We'll probably put something together for what would be middle of April. So that'll probably be the next event, and we'll try to figure out how to correct this live stream, make this a bit better, and then, yeah, go from there. So I appreciate it, Matt. Sweet. Until next time.